So let's get back to where we got up to yesterday and try and finish this off and then look at one more logic that will give you more strength. I hope you I think I didn't understand everything Professor Fabian said. My plan is to finish today some very useful logics. Then tomorrow, for people who are interested in some of the principles, no deep theory, but how does E325 work? What is inside? Not complicated, just the ideas, and maybe so normal teaching. Then on Friday, for all the people who are local, we will do some local logic, okay, on Friday. Crazy logics on Friday. And that will be for doing funny things. If you want to talk about a politician lying, you know, one politician says, he said he lied. He said no. He said his friend said that he said he lied. Politicians are crazy. And so we're going to look at some logics we need to do crazy things for the real world. But today, normal. All right. And we were looking at this example, and people were making progress on this example in first order logic, and it was this challenge problem. And I started writing the answer here, and I hope overnight we're all working all night and you have a perfect answer. So I think what we can try and do is get the answer for this one and look at some of the details. Keep going. And then see how we can go. So who finished? Finish on this one. Anyone complete? No. Yeah, the professor is complete. So let's try and look at it and then see, and then we'll look at another example. So the first one, I've started doing it. I hope you can all see that. Is that big enough? There, a bit better. All right, so I'm doing it in Spanish because I'm learning. So the first one, for all people, and I changed it to any person, and I think now the translation is better. So for any person, if the person is good looking, then there is some person who is a parent and is good looking. So I think that one's okay. Everybody happy with that? Just shout if you're not happy. The next sentence, if your oldest sibling is good looking, then you are good looking. So the important point to note here, you only have one oldest sibling, one of your biggest brother, your biggest sister. And if there's one, you can use a function here. Maybe I've used the wrong Spanish word. This is saying for all people, if the oldest sibling is good looking, then that person is good looking. I hope this works. So now let's move on. The next one is a little bit complicated. The only parents, my mother and my father, are Bob and Maggie. So we've got to say a lot of things about this. So firstly, we can say, Padres, Bob, Jeff, yeah, okay, my parent, my father, y Padres, Maggie, Maggie, Jeff. Yeah. But now we must say more, because how does my computer know I have only two parents? Normal, we know, you know, I have only mother, father, but we have to tell the computer there's only maximal two. And here's how you do it. And you want to say this for all, I'll do it, and then we look for all P. Hold on. Address P, Jeff implies P equal Bob or P equal Maggie. You see what we're saying? For all people, if it is a parent, it must be Bob or Maggie. Only two possibilities. And this is quite necessary because we know in our heads there's only two, we have to tell the computer. Okay, so I'll just, so next question. Oh, one more. That bracket is, okay. We must also say, Bob, no equal Maggie. They are different. See here? Bob no is Maggie, Bob no is Maggie, no equal. So the next ones are easy. Mayo, Jeff, equal Jill, teaching room. Let's do this. Wait, and Jeff, no Jill. Is okay. So this is here we see. La hermana Mayo, Jeff is Jill. Jeff is no Jill. This is Jeff is no Jill. Enough. Guapo Jill. Y no guapo Bob. Terrible. Okay, so Jill is guapo, Bob no. Finally, we prove, therefore, por lo tanto, Maggie es guapo. Okay, I think this is okay. Okay, so now, for everyone who has a computer, let's do this. The syntax, the axioms consistent, but use this one, new one now. Empire set. Come on in, this is good fun. Okay, those consistent axioms, 3, prove, 4, pretty picture, and go to this one. Okay, everybody. You're gonna have to get this. Okay, so then let me go. Now, we use vampire, no E, vampire. Just for fun, just for fun, to try another one. The vampire is stronger, but E is more robust. It's more reliable. So this vampire is the fast and dirty. E is a bit slower, but very clean. Yeah. So every time it works. Okay, let's start. And quite a lot of people are finished, and not quite everybody. We're getting some cases where trying to find a proof. There's no there. And that means there's a typing mistake. The lesson, several people, remember, for variables, big letters, everything else, little letters. Several people got that stuff. I want to show you something which is quite normal when you're proving things and there is no proof. So I'm going to go through another example and just show it, go through the steps. You can just watch it happening. And then I'll show you what happens when it's impossible to get the proof. So you can see in the output what it will say. So let's look at another example now. Maybe you know this example. It is very famous. Everybody know this problem, huh? Do people know this old story, huh? Old story from Greece. And maybe you know this story from Greece, from the days of Greece, from Socrates and all the people. Read the story. And now, do you believe? Oops, sorry. Is this true? Is this true? So we can think of what it will look like. Here we have Iocasti is Iocasti, Oedipus, Polonikes, Sesandros. It's the four people, huh? See, and I put here. Iocasti is a padre, the Oedipus, e Polonikes, and Oedipus, e padre Polonikes, Oedipus, padre Polonikes, Polonikes, padres Sesandros, right? No self-parent. Oedipus patricide. So I put here, he's patricide. What is patricide? Huh? You kill your father, huh? Not good. Okay. And Sesandros, I put is not. So now we must prove Iocastes is patre, a patricide is a padre, no patricide. Is this correct? Why? The problem is this, is that if we say Iocastes, if Polonikes is patricide, then Iocastes, Polonikes, Sesandros. If Polonikes no patricide, it's Oedipus patricide. So either way, it's going to work. So I did this one. And I will run it. I'll put it all into the system. I'll copy this now. Okay. I just do a proof because I know it's good. And we prove it with vampire. Okay, vampire. And here we go. And theorem, so it is correct. And I've told many people this is the wife of the man who wrote the software. So because he didn't see his wife when he was writing the program. And so he says that's what he has to put. But now we make a change, huh? Let's make it so the conjecture, we change this. We kill this one, huh? So I'm going to change the conjecture. So it's like that. We take out the not like that. Now we ask. Trying. And eventually he says, here, this is the magic, huh? If you see this, counter-satisfiable, it means definitely no theorem. Okay, counter-satisfiable, definitely no theorem. So that means you have some mistake or something like that. All right, so that's sort of it all in that. So as I promised, my plan now, we've gone first order logic. We're going to go up one more logic, more power now. So we're going to this one, typed first order logic. And maybe I need to put this also in Spanish. Okay, so now everybody knows to program in Java, C, Python, everybody can program. And we know in programming, we have data types, integer, double, character, boolean. Very normal in programming to have types. And so in logic, in this logic, again, you can have types. We add types. Why are types useful? What is good in programming to have types? Why? It helps you find mistakes. Huh? If you've got you know the types, you use KJ or whatever, you can find wrong data type, wrong data type. If there's teaching data structures, right? Wrong data type. And so we want to add data types into first order logic. And so that's what this part does now. And so with an example, we're going to add types. So everything must have a type. Same when you're programming, you put public static int in your method, or if you're in C programming, you have some function, you have the return type and the type of the arguments, the parameters. You have to specify the types. And every time you put a variable, you put int, I, double, total. You put the types of all your variables. So we must do the same thing, same as programming. Everything we tell the types. Then the E or vampire, he will check your types. If you have a type error, he says, no, 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 you have a type error. So that's how we can do some advantage. Let's look at this example. All men are created equal, per the Bible. No, the US Constitution, sorry. John is a human. John, failure. All right. There is some human who is fantastic, A grade. All right. An A grade is not the same as F grade. Therefore, we prove there is a human, not John, but somebody who is equal to John. So we have to think now about types. So we have, in this example, we have humans, the type for persona, humano. We have type for the grade, grado. And we say John has the type human, A has the type grade, F, Kali, it's grado. Yeah, grado, it's not good translation. F is grade. And now we have a function. We take the function, grade of, input, the human, one argument, return type, returno, grade. Created equal, two arguments, human, human, return Boolean, true, false. Yeah, all right. So we could write it in logic, but here's how you write it in TPTP syntax. And I have to show it in sort of English. To declare types, we say human is a type of thing. We use this special. Firstly, we say it is type, no axiom, it's type. And we say human is a type. Special word, $T type. And similarly, grade is a type. Notice the word type. Then we say John is human. A is grade. F is grade. Grade of is function. You take a human, return the grade. Created equal. You take two arguments, two parameters, human and human. You put two with a star. He returns Boolean, $O, It's Boolean in this language. So now we have, this is all type information. And now we can see all men are equal, huh? Los todos humanos son creados. Wait, I'm mad. All right, all men are created equal. Here we see the variable, you must give the type. H1 is the type variable. Okay, H2 is the type human, and then it's created equal. Yeah, grade of is a function. You take the human John, he is F. John is fail grade. Okay, there is some H of human, so H get A. Somebody gets a good grade. Okay, A no F. We want to prove there exists H. There is some H. H no John, but H equal, created equal. Okay, so this is now using type information. Let me show you some things that you can do with this. I'm going to put this into the interface. Which one should we use? I will just use, yeah, we'll check the axioms. Huh? So I'm taking, slow down. Just the axioms, no conjecture, and we're going to check for axioms are consistent using vampire set. Vampire set, huh? And we run it. Ba, 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 ba. And he says, yeah, good. He's found it. But now we make a mistake. Let's go here and we say, for example, we say, I did the wrong one. I did the wrong one. Sorry, I copied the wrong one. Let me put it. Yeah, I'm copying too fast. I go here. But it's okay. We put vampire set. Correct one. Correct. 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 Run. See, we check. Yeah, he says, okay, axioms are good. But now we make a mistake with the types. So if I go here and I say H2 is of type grade. That's bad. It's the wrong type of data. And now if we run it, he tells us, yeah, the sort grade of the intended term is not a human. He says it's the wrong type. So we get a type error. And so this prevents errors. It's a very nice way to reduce the number of errors in your work. So we have now an extra step. We check the syntax, and when we are checking the axioms, vampire sat will check the types. I do not have a special tool for types. I rely on vampire E to check the types for me when we do it. So now we can try and do a challenge. Aha. Okay, so let's work together first and think, what are the types for this example? So what are the types here? We go, starting. Yeah, the man in the middle, white shirt. What types do we need for this example? It's, am I at the right one? Yeah, it's for this one here, not the, no, we're doing this one at the top. So what are the types? Teacher, yeah, we have teachers. Me, Professor Yero, Professor Fabian, Professor Carlos. Okay, so we put type, we have teacher is a type. What is another type we need for this example? Student, yeah. Yeah, Joe is a student. What else do we have as a type? Yeah, we need, those are the types of things. We only have two types, student people and professors, teacher people, okay? But now what do we have to have? We have to have the type of objects. So what do we have? We have Joe, we have Jeff. What is he? No, Jeff is teacher. Yeah. Joe is student. Yeah, right, yeah. And anybody else? No. Now, do we have any functions? How about teacher of? So if we take teacher of, what is that? We give it a student, and the output is a teacher. So it goes from student to teacher, huh? Yeah, so this is, you give a student, and the output is teacher, okay? We had the suggestion at the beginning here, we need predicates. We have failed. Oh, come on, fingers. A-I-L-E-D. What is failed? What do we put in to failed? Who fails? Does the teacher fail or does the student fail? Yeah, so that we put in a student, and what do we get out? True, false, eh? True, false, Boolean. Yeah, let's just write here, Boolean. We're just doing it like this. What else? What's another predicate? Stupid, thank you. And what is the type of that? Yeah, no stupid professors.
Right.
Just for today, because we respect the professors. Okay, what else do we have? All right, so now we have to do that, and we have to convert that into the TPTP language. So let's. Sorry? Yeah, well, that's teacher of, huh? Teacher of student equal G of. Yeah. So now how can we do this? We have to write first the types. First thing, I always do it like this. This is the teacher type. The type of the formula is type, no axiom, no conjecture, it's type. And we're saying that teacher is the new type, $T type, special one to declare the type. Huh? And we must do the same for student. Oh. Okay. So we do TFF student type, comma, blah, 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 blah. All right, now we must give the types for the things. Like TFF, Jeff, I'm Dedu's Deckel here, he's a type. Jeff, he is a teacher. Okay, then we must do Joe. TFF, Joe, DECL, comma, blah, 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 blah. All right. And now we have to declare the functions. So we have TFF, teacher of Deckel is a type declaration. Teacher of says it's student to teacher. Then we must do the predicates. TFF. Sure. Of the declaration. Yeah, it's like you declare if you in C programming, you declare your functions. Yeah, I use a different, I like when I'm declaring a type, I put underscore type. And if I'm declaring an object, I like to put underscore declaration. Yeah. More complicated. Yeah, and in fact, quite complicated. Yeah, good question. It's you need subtypes, and like because we have humans, and then we have like teachers and students, but then you want to have people who are both, so you get multiple inheritance. C++, and E can no do it. Vampire can no do it, but there's tricks. I have a good master's project for this. Good question though. Failed decal type. So what is failed? It's something, and we need TFF. Stupid. I want to show you the syntax here. My fingers are not doing good. Here we have two arguments. No, it's one argument, so we can do stupid is the same. Okay, so now I've given you the beginning. Go. It's now for you. Haskell. Yeah, it's quite easy to take a Haskell program, convert it to a logic, and then verify. Very common for 10 years. Okay, who needs help? I will start doing it. Which one? Stupid we say. Stupid. What we say is no stupid job. Let's see. Let's see. Yes, yes.
Yo
Yo, coming.
How come I ask for the type? I need to know if teacher or professor, I need to ask for the type.
Yes, give me an example. You want to say if it is a teacher, then
The same for all C.
type. No, you just put the type.
How do you type?
Colon, like, see here. I did.
C student?
Yeah, I put for all S of type student. Yeah. No, it is because teacher of is function. Yeah. So teacher of Joe is only got one possible value. It's the function. You know? If Joe has many teachers, then we do a different way. It's a good, yeah, there's two. Here we think, does everybody have one teacher or many teachers? You have many, huh? Yeah, then we have to change it. I'll show you down here. We would say, we would have to do this. PFF teachers equal. We would take away this one. We take away this and we add this. So now it's a relation, huh? You can have many. So yeah, so that's nice. So this is normal, many, because we can have Jeff, Ramon, Fabian, Ramon, Jeff, Emily. Yeah, you can have many. But like this, we have a function, only one. Yeah. So there's two ways. Okay. Got it? Working or you confused? Well, then you need help. When you finish, you will not be able to know. So let's try to finish now with these parts. That's for you to finish. So how do we deal? What is the dots there? We just want to say the teacher is a type. So here we must do like this. Student is a dot type. We're going to fix this. So you see how here we real. Okay, so now we are saying that the things that the teacher introduces is like in the real it's a new plan. So now you put those on the teacher. This now bracket done. Finish. Joe is a student. Yeah, dot. You make it Joe is student.
Vamos a negación.
The line of Joe is not stupid. Okay, Joe is not stupid. Yeah, somebody you don't have enough of the stupid students. Somewhere in there, that's what something like that. Okay, so look careful. I think it is you are missing one closing parenthesis. No. This is okay. Now we're going to say, how do we say fails? So we see. It's a comma. No angle. So now we want to say what is failed. When you say failed, student fails or teacher fails. So it is it's a function. You put in the student, out comes boolean. Yeah, true, false. So we want to say fail, we dot in this case. It's 6 sentences. No. This guy. Yeah. So now what is going in? So what goes into the function? Students. Student. And what comes out? Boolean is dollar O. Dollar O. Close bracket. Okay. You do stupid. Hey, we have a winner. He's got a proof. Yes, winner. Give this man an A grade. Alright, now we have the teacher of Joe. Small letter. So now the next one. Okay, you can put in some more and then I'll help you. A little bit too hard. Sorry. You manage it. Did you finish it?
I have some
Too hard.
The name of the
Infinite random. No, of course. Anything. But for me, I like to put something to help me remember. I have to show you how to do infinite set. Could you ask me? And I checked with Professor Carlos. I think this for all S of type set, infinite S is equivalent to saying for all E of type element let me just, I'll put this down here so we, member E, if E is a member of S, then implies infinite the difference between S comma singleton E. Singleton E. I need to make this. Sorry, the screen is not showing it. Hold on, I'll make it so you can read it. So you take an infinite set. If you take any member, pull them out, still infinite. That's how you write infinite set. Okay, so what I suggest we do now is let's finish this together. Are you close? You finished? Are you close? And you finished close? He's finished. Finished you close? You near? You got it? Let's do it together. And we finished now. We can do it together. So let's see this one here. Has anybody completed? We complete this. I think people will keep working. Work. I help you. Yeah, right. Yeah. But we finished today. What's going on? So you see, this one is correct. So it's the one after Jones is stupid. The next one. The next one is the one after Jones is You see, this is the quantifier for S. And you need that S is being used here. Open parentheses, close. So the quantifier and down to here. So that means that this S is valid from here. If you don't put that bracket, S is only valid here. Same one with the T. So that the T is valid from here and open parentheses. You say the T is valid from there to there. Because when you have a variable, you have to say where it is valid. same problem. All right, how's the back row doing? How you doing? Getting it, it's good to know. Yeah. Okay, you need because you need to have an open bracket here because it fails imply the big thing to show the big thing before the result of that.
¿Qué complejo? Que tiene el mismo propio y falla.
Checking sessions. Okay, so let's go. So this one is correct. Only teacher is correct. The next one, oh, TPTP World. If you just want to listen, this is a common problem. I think 3 or 4 people have made this mistake. So let me just show you what's going on. When you write a formula, something like this, as 4S of type student, colon, then we want to say, it's the example. Here it is, failed S implies, put it in here. And now in here, there's a lot of things, whatever, dot, dot, dot. And somewhere here, you have S. Huh? You see, this bracket is necessary because the S variable, we want to show where the S variable can be used, where it is allowed, where it is legal. And so we put the bracket like that to show the S variable is in all of that place. Yeah. Yeah. And if you leave out the bracket, if I do this, then the S variable is only here. So it's no good. So we must have the parentheses like that to show the S variable can be in all of those places. Let's go. So you see your This implies. Okay, I put the answer for people can finish with some hints.
So, lado.
So in English, it's a same teacher. It's the same the same teacher of Joe. Hey, buddy, both focus up. See here? Yeah, we see here. It's the same teacher. It's the same teacher. Let's go. Yeah. This A has the same teacher as Joe. Yeah, I should put it. Yes, you're right. Put it in the same teacher. In here. I need to put here. Same teacher. Mm-hmm. So is here. I need to make this smaller, maybe. So, other student A no S. Oh no, no Joe. It's a S, huh? No. No, you're correct. You think S? Yeah, S. Yeah. Yes, correct. Correct. You are correct. You are the winner. I made a mistake. Yeah, correct. No Joe. Okay, thank you everybody who's watching the recording.
Universidad Nacional de Colombia, proyecto cultural, científico y colectivo de Nación.